Come on guys, let's learn Docker today. In this video, I will show how I learned Docker, and at the end of the video, you should be able to teach Docker to others. So that's the end goal of this video. So to learn Docker, what I did is I created a cloud account. You can create any cloud account like AWS, GCP, or Azure. I created a GCP account, and they will give a 90 days free trial, and you can install any VM, and you can install Docker on that VM, and you can practice Docker on that VM. So to install Docker, first I will show how I created a VM. So in GCP, you can create any VM by going to Compute Engine, then click on VM instances, and then I can click on create instances. So if you know how to create any VM on GCP, then you can skip this first 2 minutes. Then I will directly show. You can directly go for a Docker part. So when you click on create instance, then you can keep all of this as default, and you can go for boot disk. You can change it for Ubuntu. I'll show how I'm comfortable with Ubuntu. That's why I'm choosing Ubuntu now. Then also I will change this size to 50 GB. 10 GB is enough, but for safer side, I will keep it to 50 GB. Then I can click on create. So this will take couple of seconds to. So VM is created now. That this is the instance, and I have to log into that instance using SSH. So to log into SSH, I first have to add my SSH key into this instance. For that, I will create an SSH key. For that, I can use a command SSH keygen command. I already have the command like SSH hyphen keygen and the type RSA type and the number of bits, that is 4096, and the username is Sandesh2026 to log into my instance. So first create a pair, then I can give the default location and I will override the key. Once I created a key, then I can copy that public key into my instance. So public key path is this dot pub path. So that will show the path now. I have to give it in double quotes because there is a space in the path. So I can copy this key and I can paste that in my instance. So Control C, and I can edit this instance, and I can search for SSH and SSH keys. Here you can add item SSH keys. You can add item and paste that key and save. Now SSH key is added into this instance. Once that is done, I can log in using SSH command to that instance. For that, SSH, then username, that is Sandesh2026 at, and the IP address. For IP address, you can copy the external IP of that instance. This is the external IP. And I will go here and paste that. Then say yes. So now it should automatically log in into that instance using that SSH key. So now I am in this VM instance. Now next goal is to install the Docker. I have to install Docker on this Ubuntu instance. So for that, I can just go for Google and search for Docker installation on Ubuntu, and I will get the documentation. I can follow those steps. this is the documentation. Then these are the steps I have to execute. First, I will copy these commands. This will install all the dependencies that is needed for Docker. So it will take a couple of seconds. So this is done now. Next, I can copy next command. This will install dependencies and also Docker engine. I'll paste this. So this also takes a couple of seconds. So that is also done. Now Docker should be installed. So to verify, I will just run a hello world image that is also in document. So sudo docker run hello world. Once I run this, I should get the response like hello from Docker. If this response is coming, then Docker is installed in this system. But it's installed as a root user. That's why I run sudo. So to use Docker, now I can just switch the user to root. So now I'm in root. So Docker is installed now. So next goal is to create a application using Docker. I'm going to create an application using Docker. So before creating application using Docker, normally to create an application, what we need? We need code, source code we can say, plus dependencies. Any application will have source code plus dependencies. Correct, correct. So now I'm going to create an application. So I need code. For that code, I'm not going to write any code now. I have sample code and I'm going to copy that code into my Ubuntu instance. So my code is in GitHub. So I'm going to log into GitHub and I have the repository here called as Node.js Docker. I'm going to execute this application using Docker now. So first I need code. That's why I'm going to copy this code to my Ubuntu instance. For that, you can use git clone command. This will just copy your code to your instance. Git clone and the paste the URL. So that is cloned now. And if I do ls, this Node.js Docker is there in my instance now. Then change the directory to that. And if I do ls, all the files are there here. Now I have the source code. Next, what I need is dependencies. So for dependencies, Node.js application, it keeps in a file called as package.json. So in package.json, it will list all the dependencies. So here you can see express and body parsers are the two dependencies we are going to install that already listed in the package.json. So we have both the source code and the dependencies now. So for example, if you are not using Docker, then if you want to run this application in any VM or local, at that time, what we need is to install or execute this application or to run this application. We need one first thing is we need a platform, that is Node platform. These are the steps to execute in a local. Then what we need is dependencies, that is package.json. So we need to install that dependencies. To install Node dependencies, we use command npm install. And the third step is we need to run the code. For that, we have the command node and the file name. The main file name is server.js. Then obviously we need source code also. We need a platform and we need to copy or we need source code. So we need platform, we need source code, we need to install the dependency. Then last step is we need to install or we need to run the application using node server.js. These are the steps to run our node application in any VM or any local server. So to run this application in Docker, we need something called as container. Container is nothing but you can consider this container as a VM that we create an Ubuntu VM. It's similar to VM, but the difference is this container will not have its own OS. We create this container on top of our VM, Ubuntu VM, and this container will share the VM, the OS from the host only. It will not have its own OS. That's the difference. So we are going to create a container now to host this application, this node application. So we can't create a container directly. To create container, what we need in Docker is image, or we can create consider this image as a template. So we create a template first, and with that template, we can create multiple number of containers. So Docker image is nothing but a template, and we can create number of containers from that image. So can we directly create image? No. So for that, we should create a file in Docker. That file we call it as Dockerfile. So first we need to create a Dockerfile. This Dockerfile is nothing but it has number of instructions. You can consider it as a group of instructions. So first I'm going to create a Dockerfile. Then from that Dockerfile I'm going to create an image. Then from that image I'm going to create the container. So create image, create Dockerfile. Where I have to create a Dockerfile is just where the source code exists. In that path, I'm going to create a Dockerfile. Docker file. So we add Dockerfile. So now I have to add the steps. The steps I've already explained. These are the steps I have to execute. First, I need a node platform. That is first step. So in Docker, to we are not going to install the node platform now. We are just going to pull the node platform image. So similarly, we copied the code from GitHub. So source code from GitHub. We can copy the image from Docker docker.com. So there we can search for node. Once you search for node, you will get the official image. This image we are going to use. So first is node image we need. So node. So to copy or pull the image from Docker, we use command called as from node. So this is the base image now. Node is the platform, and that node platform image we are going to use. On top of that image, the next step is we need source code. So we need to copy the source code. For that, we have the command copy. The source code is in this directory only, current directory where Docker file exists. So I can just give the dot, and I have to copy this code inside the container. Inside the container, I can create a folder called as slash app. Generally, we create slash app directory and we copy that code to that directory. You can create any directory. You can copy that code to any directory, but I choose slash app now. Once the source code is copied, what next? Next step is I have to install the dependencies. Npm install. So next command is npm install. Npm install. But in Dockerfile, the syntax is any command to run, we have to use run. Run npm install. So run npm install, what it will do is it will install the dependency that is listed in package.json file. But this package.json, it should know where it exists. It should know the directory of that. We should install npm install where a package.json is there. In that path only we have to execute that command. So for that I have to change the working directory first. That package.json is in this slash app directory now because we copied the source code to slash app. So we have to change the working directory. That for that we have the command called as work dir, then to the directory that is slash app. So we are in slash app directory, then we are going to install npm install. We are going to run npm install. So, so dependencies are installed now. Next step is we need to run the application. To run the application, we have the command node server.js. Server.js is the main our application code is there in this file. Are we going to use run now? Run node server.js. We are not going. This is wrong actually, because all these commands will run while creating the image. But this one, this is running the application. Running the application should be the last step, and it should run only when the container is created. While not, it is not creating while creating the template or image. This will run while creating the container, not creating the image. So all these steps run while creating the image. This will run, last step will run while creating the container. For that, instead of run, we have to use cmd. So application we run once the container is created, not when the image is created. That is the difference. Remember, that is the difference between run and cmd. And the cmd syntax is different. For that, we have to cover this in square bracket, and we have to give it in double quotes and separated with the comma. This is the syntax. So cmd will run while creating the container. Run will uh, execute while creating the image only. So you have to install the dependencies and copy the code, everything while creating the image template. That template have its all of these steps. That image have all of these steps. It will not run the application while creating the image. Just remember that. I repeated multiple times that. So next is, so this should create my application inside the container. But one more thing is, this is the Node.js application is a web application. It will have its own port. So if I go to server.js, this has its own port, and it's listening on app port 80. So I have to open that port. I can include that steps also in Dockerfile. So that application will listen in on port 80. For that, I have to use command called as expose port 80. We have to expose that port. So all of these are the instruction. So this group of instruction we can call it as Dockerfile. Just remember the difference between run and cmd. That is quite important. So I have created a Dockerfile now, and that Dockerfile is in same directory. So once the Dockerfile is created, next step is, so now Dockerfile is created. Next step is we have to create an image. To create image, we have the command called as docker build. Docker build, and you have to give the path of Dockerfile. Dockerfile is in this path only. That's why I am giving the dot. So Docker build dot, it will create take couple of minutes to pull that node image, that is the base image. Then it will copy the code, then install the dependencies we're using npm install. Then it will the that last cmd command that will execute while creating the container. So this will take a couple of minutes now. So it took around 30 seconds to create this image. So Docker build is done now, and to know whether the image is created or not, we have the command called as docker images. Docker images will list the images in this host or in this instance. So hello world image that I created earlier to know whether Docker is installed or not. So this is the image created now. It has no name, but it has an image ID. So now image is created. The next last step is we have to create the container. So image is nothing but a template, and using this image I can create multiple containers also now. So first I will create one container. For that we have the command called as docker run, and run what? Run this image. So this is running now. I should be able to see it in my browser. How to access this? I have to paste the external IP port, IT port. This will not work actually. I will let you know why it will not work. So it will result in set can't be reached. So it didn't work. The reason is we have to give the host port. The 80 is the container port. If I see Dockerfile, I see the Dockerfile here. I've added expose 80, but this is just a documentation step. This means that application is running on 80 port. That container is using 80 port. This is the documentation step, and if you not added this step also, it will work same way. This is just a documentation step, and but as a best practice we should uh, give this expose 80 port, so that there is no need to check the source code to know which port container is using. Using the By just checking the docker file we will get to know which port container is using. But the main step is we need to run while running the docker run also, you have to give the port. Docker run, I can give -p. There's the publish to which port. I can give any host port. First is container port is 80, that I know, and the host port I have to give before that. Host port, any port I can give that runs on this instance. I can give 3000. You can choose any port. I will choose 3000. Docker run -p 3000 colon 80. Then I have to give the image ID. So container is running now. And if I go here and external IP colon 3000. This also won't work because in GCP you are not opened 3000 port yet. You have to open 3000 port also. So this is also said can't be reached. So I will just go here and I will open the port 3000 now. So this is our instance, and I can go here and view network details. Here in firewalls, I have to open 3000 port VPC firewall rules and allow HTTP. I have to open 3000 port. So before that, in instance also we have to allow HTTP and HTTPS. Instance, if I go here and if I edit, I have to allow HTTP and HTTPS traffic in firewall. If I click on save, so it's better to while creating the images, while creating the instance only you allow HTTP and HTTPS traffic. I forgot that. That's why I came here and I edited my instance and I allow both HTTP and HTTPS traffic. Now I can go to my network and I can open port 3000. View network details and firewalls, VPC firewall rules, and now I will have the option called a default allow HTTP role. In HTTP role, I am going to edit and I will add only 80 port is open by default. I'm going to add 3000 port also and click on save. Once this is done, if I refresh the screen, the application should run now. Yes, That's it. So you have created a application using Docker container. So if I add anything here, channel goal, land Docker, set channel goal. Then if I go here and in the terminal also, that output will, it will show that output, land Docker. So this is how I can you can create an Dockerized application. So first you have to create a Docker file. Then using that Docker file, create an image. Then run that image. You'll get a container. That's it. So now I have created a container. Next, what if I want to change the code? So code is initial code is there. Now if I want to modify that code and that changes should reflect in my applications. In that case, first I will change the code vi server.js. I can change anything for this just for testing. So I will click on my channel goals. I will just add yes here instead of my channel goal. Now it show my channel goals. So save the file, colon WQ, escape colon WQ, then it save the file now. So will it automatically reflect here once I change the code? No, right? Should not. Then if I start or stop this container, will that work? I will check whether the container is running or not. Now for that we have the command called as docker ps. Docker images is for listing the images. For listing the containers, we have the command docker ps. PS you can say processes. So there are two containers. One is running on 80 that I created earlier, but now the main container is using 3000 port that is still running. So I will restart this container now. I will stop and start the container. So stop the container, you have the simple command called as docker stop. These commands are self-explanatory. Like to create image, we docker build. To run the container, we have docker run. Or create the container, we have docker run. Then docker ps for listing the containers, and docker stop is for stopping the container. Docker stop, and they have to add the container ID. So it will take a couple of seconds to stop the container. Then I will start the container again. So it stopped now. I'm going to start the container again. Then if I go here and refresh, will it reflect my changes? No, right? Simple restart of container will not reflect your code changes. Then I will stop it again, and I will recreate container using that image. I'm going to create container again now. Docker run -p port 3000 and content 4080, and I have to add image ID. Image is this. So will this reflect my changes now? No, still my channel goal only. It's not goals. So even if I create the container again, it will not work. So if I modify the code, then I have to recreate the image only. So if I click on cat Dockerfile, if I type cat Dockerfile, it will show all the command like from node, copy the code, then work directory, and these are the steps. So copy code is running when I creating the image. So while creating the image, it copies that code at that point of time. At that point of time, what is there in code, it will copy it while creating the image. So if I modify the code and if I want to recopy that modified code, then I have to create the image again. So image is I can consider the read only. Once the image is created, we can't change anything there. This is image is read only, and the container is read write. This container I can go inside that container, I can modify anything, but image is read only. Once it is created, it's read only and it's locked. So whenever the code is changed, then I have to create the image again. So for that, now I'm going to create the image again that will reflect my changes. Before that, I'm going to stop my container again because I'm going to use that 3000 port only. So I'm going to stop that container now. That container is stopped now. I think no, I think if I go Docker PS, I pasted a earlier container ID, I think. Docker stop and stop this. Now I'm going to my build image again. Docker build. The command to create image is docker build and path of the Docker file, that is dot. So it's recreating the image and with the new source code with the new changes. So whenever a developer changes their code, they will generally create a new image from that. There are other ways also, but general ways they will create a new Docker image. Now if I want to list that image, I can run Docker images. And now there are three images. One is hello world, and this is 14 minutes ago, that is first image, and now that is 17 seconds ago, that is recent image. Now I have the image. I can run the container from this. Docker run -p, the port 80 is the container port, and the image ID. So if I refresh now it changed to my channel code. So modified code is reflecting now in my UI. So this is how whenever developer modify their code, they have to recreate that image. And once they recreate that image, then they can start the container again or create a container again from that new image. So just remember the image is read only and it's locked. But container, I can go inside that container and I can execute the command. For example, I have the container now, and to log in into that container, I have the command called docker exec. First, I need the container ID. For that, I can run docker ps, then docker exec -IT. That's interactive mode. I will explain this later. Don't confuse now. Paste. Then I have to add the bash. For that, bin /sh I can add. So docker exec -IT. If I execute this command, my terminal will go to my container. Now I am inside my container. If I do ls in inside my container also, all of these will be there. Dockerfile, readme, md, node modules. These all will be there. And inside my container, node will be there. This node, everything will be installed inside my container, not in my host Ubuntu VM. If I give node version, Node.js is there, Node.js 22.4 or npm version will be there inside my uh, container. This I am executing inside my container, so everything will be there. Node, npm, all the dependencies are installed inside my container. But if I exit this container and if I add node version, it will not be there in my VM. In container it's there, but not in my VM. So that's the advantage of container or Docker. So all the dependencies will be installed inside our container, but VM in VM it will be the clean VM. So the why Docker is comes in first place is earlier what happens is like as a developer I write my code and I will install my all the dependencies on my machine and I execute and everything works. And if I move that code to for example testing team, then if they execute, that will not work because it might not work because they will have different version of dependencies on their machine. It might work on in their machine. That's the use case. Like for example, code is working on dev environment. Then if I move that code to prod environment, then it might not work because the dependencies on different environment might be different. To avoid this problem, Docker comes in place, comes handy because in this in Docker we saw, right, we create an image, and that image that involves source code plus dependencies also. So if I share this image to anybody, or any of my colleagues or testing team, or any environment, dev environment or prod environment, if I run this container using that image, it will install that particular dependency only inside that container. So avoid these dependency problems and everything, we have the Docker. So that is the advantage of Docker, and this Docker is very lightweight because it don't have its own OS. This Docker container is using my host Ubuntu OS only now. So that is the advantage of Docker. One is lightweight, and another thing is dependencies. Everything will be packaged, and it can be used anywhere. That's why we call it as portability. So portability and lightweight is the main advantage of Docker. I didn't explain the theory earlier, but if I explain now, I think that should be better. That's why I explained those things now. So next, so I have created image, and I have created the container also now. So I will go to next advanced steps now. So I'm going to stop the container now. Then I will go for other steps, Docker PS and Docker stop this container. So it will take a couple of seconds. So whenever I run Docker run, the terminal is attached to my this container. For example, Docker run -p port, and the container port, and the image ID. I don't have image ID. Okay. First I will run Docker images. Docker run -p 3080, and the image ID. This is the image ID. So terminal is attached to this. This is running in a foreground mode, or it is in attached mode. We'll call it as attached. So if whatever I give here, for example, learn KTS, those will be attached to my terminal. So those output. If I give learn Docker now, see this. So my terminal is attached to my container now. So if I don't want to run the Docker like this, like I want to run this application in background, my terminal, I want to use something for some other commands I want to run. For that, in that case, if I want to run this application in background or in detached mode, we'll call it as this mode. What we are running is by default Docker run will run in attached mode, attached to my terminal. It means, so if I want to run it in a detached mode, then I have to use command called as I have to add any one more flag, that is -d. So first I will stop this container now. For that, docker ps to list the container, docker stop this container. So container is stopped now. Now I am going to run this in a detached mode. For that, docker run -p 3080. This is say, just I will add one more flag, that is -d. So it will give the container ID, then it will exit from that container application. So, but the application is still running. If I do docker ps, the container is still running, and this is started 10 seconds ago. And if I go to browser also, it's still working. But in terminal, it running in background. So if I give anything now, it will not show in my terminal. Correct? Anything, it will not show in the terminal. So if I want to see if I want to see the events or logs, in that case, I have the command called as Docker logs. When I run it in background, I can't view the logs, right? In that case, I can use the command called as Docker logs and the container ID. Container ID is this one. So it will show now Docker learn Docker that I have added as input. And if I add one more thing like some test, so it will not show. I have to show Docker. I have to run Docker logs. So it have added one more thing test. But if I want to see the real-time logs, then I can use the command called as Docker logs and -f also. It will -f is for follow. It will follow that container. So if I now it is similar to in the attached mode now. So if I give anything, it will reflect in my terminal also. So this is how I can run Docker container both in attached and detached mode. Normally we run it in detached mode because I don't want to stuck my terminal with that container running. So I have to use other commands also for that reason. I generally everyone run container in a detached mode. That is done. The next command is so docker start and docker stop that we have already learned. I've executed that multiple times. So next is we have created an application that is a web application. So generally Docker we use it for running the web application or any multi-services microservices application also. That comes later, but now if I want to create an application, simple application using Docker, like simple like adding two numbers, in those use cases also you can use Docker. So I will give that example also now. First I need source code for that. So I will go to GitHub and I have one more repository, and I will share this all the repository links in my description of this video. So we'll go to Python Docker. This is one more sample application. I have the sample code. So this code is nothing but we have to give a minimum number and maximum number, and it will print the number in between these two numbers, minimum and maximum number. It's a simple use case, and for this simple use case also you can use Docker. That I will show now. First, I'm going to clone this code similar to first application. So I'm going to change the directory, and now I am here. Now the command to copy the code is git clone. Oh, something happened. Git clone, and I will copy it again. I think H was missing. So code is copied now. If I do ls, Python Docker is there now. So I have the source code, but this application doesn't have any dependencies. So if I want to Dockerize this application, what I can do? We have to create a container. To create a container, we need image. To create an image, we need Dockerfile. So first, I'm going to create a Dockerfile now. Dockerfile. First is platform. Which platform it is? Python. So go to Docker. If I search for Python, it will have official Python images. Python. So we are going to use this image. So if I come here from Python, this is case sensitive. If I give capital P, it will not work. From Python, what is next step? I have to copy the source code. For that, we have the command copy. Source code is in saved directory as Dockerfile. So dot and any directory to copy inside the container, that is slash app. Then what next? I have to run the application. To run the application, I have to run Python and the source code name. Source code is in sample code.py. I have to run this py file. I have to run this. For that, I have to add Python sample code dot py. I obviously I want to run this while creating the container, not creating the image. For that reason, I have to use cmd. And one more step I missed is I have to change the work directory also, because the sample code.py is in slash app directory. For that reason, I'm going to change the work directory to slash app. Correct. Next, exposing port, that is not required because this is not a web application. It's a simple Python application, so it doesn't have any port. So that's not required now. So only these four steps. Then I can save the file. Now I have the Docker file. What next? I have to build image, Docker build, and the path of the Docker file, that is in the same directory. So it will start building the image. It will take a couple of seconds now. So image is created now, and if I run Docker images, here we go. In 19 seconds, it created an image, and I'm going to build that, run the container from that image. Docker build, then sorry, Docker build is already done. We have already created the image. We have to create the container. Docker run, then hyphen p is not required because it doesn't have any port. So Docker run and image id. So we got an error. Why? Because this application expects inputs minimum number and maximum number that I have to give while creating the or running the application. So for that, I have to run this in interactive mode so that I can give the input. So for interactive mode, what is the flag? If you don't know any flag, if I forget any flag, then I can run Docker run. I can run help. It will list. So I have to run in interactive mode. For interactive mode, I have to give hyphen I. It will keep stdin open even if it's not attached. So I have to attach the terminal also. So generally, this interactive mode will be combined with hyphen t also. That is tty allocate as sudo tty. So hyphen I t. So it will interactive mode and it will also give a terminal. So Docker run have to give in IT. Before that, I have to know the image. I have listed the image now so that I can copy the image ID. So Docker run, then interactive mode and the terminal. Docker run hyphen IT, then the image ID. So now it gives the option to enter my minimum number and maximum number. For example, I will give 6, I will give 10, and it will give the number between 6 and 10, that is 10. Or if I run it again, 5, 8, it will give the number 8. Any number you can give, like 1, 9, sorry, give the number 1. So it will just give the number between this minimum and maximum. This is the random logic actually. So rand int and minimum number and maximum number. So that is this simple application you can use in Docker run -it. So if I run Docker PS now, this application is not there. This is the old application that is running in 3000 port. This is I think created 35 minutes ago. That is first time I tried to run it on 80 port. But this container is not running now, because once this container is run, once it is created, it will stop. It gives the number between minimum and maximum number, and it will stop that container automatically. That is because this application job is just giving that number. That's it. It won't run in background or anything. So if I give docker ps -a is for listing the all containers, both started and stopped container. So if I go here, and this is the this exited 1 minute ago or 0 minute ago. So this is the container. There is a Python code container. So if I start this container again, docker start, paste. So it will start, but how can I give the numbers, like minimum and maximum number? And remember one thing, docker start always run in detached mode by default. While running docker run, it by default it is running in attached mode. And if I add -d, then it will run in detached mode. But docker start, by default it will run in detached mode, and if I want to run it in attached mode, then I have to give docker start -a. This will run in attached mode. So terminal is attached now. Remember that difference between docker start and docker run in detached and attached mode. By default, start in detached mode, run is in attached mode. And now I have to give the interactive mode also. In for that case, docker start. Before that, I think the container is still running now. I have to run docker ps, docker stop. This one. So it will take a couple of seconds to stop the container. Once it's stopped, I am going to recreate my restart my container using interactive mode. For that, docker start -i. Also, I have to run this in attached mode only. So -ia. Then give the container ID. I is for interactive mode, A is for attached mode. It will give one more number. So that's it for interactive mode. So interactive mode, I have to give add the flag -i. So usually it is combined with the t -it. I can give. What next? Next, for example, if I want to copy my host file into the container, for that we have a command called docker cp. I will show that. First, I will go to my previous container, because I can't show that copy files here, because that container will stop by default in Python application once it gives the minimum and maximum, once it gives the number between minimum and maximum number. So, for example, we'll go here, change the directory first, then ls. Okay, so first I will create a container. If I do docker ps So container is already there, so I'm not going to create it again. So to copy the file, first I will create a file here, simple file, text file, and I will add some content. That's fine. So if I do ls now, there is one more file, test.txt. Now I want to copy this file to inside my container. For that, I have the command called docker cp. Then the source path, that is source is test.txt file. To where? To inside this container. Copy to this container. And the container path is slash app. I can give. Inside this directory, I want to copy this file. So copy successfully copied to this container. How to verify that? How to go inside that container? What is the command for to going inside the container? Docker exe. And the interactive mode is -it that I have already explained. And the container ID and the shell is in bin/sh. If I do ls or pwd print working directory, that will be there in app directory. So now there is one more file called test.txt. That file is copied from my host to container. That's how you can copy the file. So container is I already told read write layer, so I can modify the files also here. But image is read only layer. Remember that. I will exit, and if I want to do it vice versa, like I want to copy the file from container to my host. Host is nothing but my Ubuntu instance. Whenever I say host, that is my Ubuntu instance. So I will delete the file now, and I will recopy from my container docker cp. Now source is my container. This is this container, and the path and the file name, that is test.txt, to where? To this location. So copy it, and if I do ls, the file is there now. So that's it. That's how I can copy the file from host to container and container to host. We will not use this command frequently, but the use cases like for example, inside the container, that tab generates logs, and if you want to inspect that logs, then at that time I can copy that logs to my host. Then I can verify those logs. That is some use cases for Docker CPL. So like copying the logs file from container to my host or my instance. So Docker CP is done. The next command is next is like we have created a lot of images in container. Now, if I want to clean up for housekeeping things, I can clean up my images and containers. For example, if I run Docker PS, these are just to list the running container. But if I run PS-A, there are a lot of containers. I want to clean all these containers. For that, I have the command called as Docker RM. So before running Docker RM, I have to stop the container. So if I want to delete this container now, I have to stop this container first. It is still running. So to stop, obviously we have the command called as docker stop. I have used this lot of times in this video now. And the container ID. So it will take a couple of seconds to stop the container. And if I run docker ps, so now only one container is there. That is this container. Hello world, hello world container. No, this is not hello world container. This is much before like before I created for 80 port. In that time it created this container. I'm going to stop that container also. Docker stop. So now if I run docker ps-a, there are a lot of containers that are every container is in stop state. So now if I want to remove this container, I can run docker rm and the container id. And if I want to delete multiple containers, I can give space and I can add one more container. So it will delete these two containers now. And again, if I run docker ps-a, so those two containers are gone, other containers are listed now. Now, for example, I have 100 containers in this host, then I can't give all the container IDs, right? For that, I can run docker rm, then I can pass the command docker ps-a, docker ps-aq. So this will delete all the images. If I run docker ps-a now, all containers are cleaned. Similarly, for the images also same. For example, if I run docker images, these are the images. So if I want to delete an image, I can do docker rm I now image. Docker rm is for delete the container. Docker rm is for deleting the image. So if I give docker images now, so all these three images are listed now. Then if I want to delete all these three images, then I can run docker rmi. I can pass another command docker images. So all these images are deleted now. And if I run docker images now, there are no images now. So so what I've already explained is like whenever we change the code, we create a new image and we create a new container. In that case, stopping the container and keeping it in stopped status is it doesn't make any sense. So whenever I stop the containers, I have to remove the container by automatically. For that, whenever I running the command, running the container only, I can add one more flag so that it will whenever I stop the container, it will automatically remove that container. For that, to show that, I'm going to build the image again because I have already deleted all the images. So docker build dot. This will take a couple of seconds. So next command is docker run. Docker run hyphen it. Sorry, it is not required. Docker run hyphen d will run it in detached mode, and the port is 3000 and 80. And I can give one more flag is hyphen rm. This will make sure that container will be removed whenever I stop that container. So it will not will be there in stopped status. It will just remove that container. So if I run this and if I run docker ps, this container is running now. And if I stop this container, if I stop, it should remove that container also. It will not just stop, it will remove the container because I have added the hyphen rm flag. Whenever I stop this container, it will remove. If I run docker ps, it will not show. That we know. We know stopped container will not show in docker ps. If I run docker ps hyphen e also, it will not show because it already removed that container because of this hyphen rm flag. So that is the use case of rm flag. Next is, so now I have created only one container. If I want to create multiple containers using this image, at that time I can have, for example, I want to have the container one is in 3000 port and another one is in another port. I want to have this container, same container. So 3001, same image but different container. So one is running on 3000, another one is running 3001. So if I go here and search for that external IP 3000, it's working, and 3001 also it should work. That external IP I have to copy from here only. and port is 3001. One more thing we have to remember this. I have to open this 3001 port in my GCP firewall also. Can I just this HTTP firewall rule, default HTTP allow HTTP rule, and if I click on edit, then I have to add one more port, that is 3001, and click on save. Then only it will work in my browser. Yes, it worked. So now the application is running on both the ports 3000 and 3001. That's why we build image once, and using that image we can create multiple containers. That's why image is nothing but a template. Using this template we can create multiple containers. So that's it about this. So if I stop this containers, now it should automatically delete those containers also. We'll do docker stop. This will take a couple of seconds. Sorry, I add the image ID instead of container ID. So now I stop the containers. The next thing is for now I am using this image, but in real world multiple developers will work on same image, same application. At that time I have to share my code or my image. So we can share in two ways. One is I can directly share my raw Docker file so that they can build that image from that Docker file, and it will have same dependency. That is one thing. But generally, the best practice is we have to share my image. So I have the image now. I can share that image to anyone, and they can just run that image so that they will have same environment. For that, for sharing the image, we generally use Docker up kind of registry. So like sharing the code, we have GitHub. For sharing the image, we have Docker up. So this docker dot up dot docker.com is the registry. This is the public registry, but generally in organizations or in companies, we use private registries. Any private registry like AWS ECR or in Azure ACR, like this. There are a lot of private registry like or any artifactory like Nexus also we can use as a private registry. So now I am going to show it in Docker Hub. So how we can share the image and multiple users can use that image. For that in Docker Hub, I have to log into Docker Hub. Then to share the image, first I have to create a repository. So create repository. I'm going to create a public repository also, public repository only, and I can give a name for uh, this repository. I can just give a name as Node.js app, then create. So this will create a repository now. So once the repository is created, now I have to push this Docker image whatever created. So if I push this image to Docker up, then anyone else can pull that image and they can use that image to create a new application. So now Docker push, and this is the command I have to run. Before that, I have to tag my image. So and it should be in this format only. For that, tagging is nothing but you can say the naming your image. For example, if I run Docker images now, there is no repository or tag. It will say none and none. So for that, I can use Docker tag to tag the image with the image ID. Tag can be like this. I can give like this. Send this repository name slash sorry username slash repository name colon the tag name. So if I paste that, and the tag name can be generally it is version, can be version 1.0. So it gave an error because I have not specified the image only. So I have to this image. Some error. Let's see. I think I have to give this vice versa, like Docker tag, first image ID, then the tag name. Then if I run Docker images now, it will have like this. Repository is this, tag is this, and this image ID. Now I have the tagged image also. This is one way. Another thing is while creating the image also, I can give the tag. For example, Docker build dot is for creating the image, but before that I can add a tag hyphen t and give the tag given node app version 1.0 or 1.1, something like this. So if I run Docker images now, images. So there are two tags. One is node app 1.1 and is this app that I created earlier. So creating tag, I can use Docker tag command or Docker build hyphen t command. Now once I have the tagged image, now I can push that image to Docker app. Docker push to this repository. You have to give colon actually. This should push the image to Docker hub. So it failed because access denied. So not anyone can push their image to my repository, right? It is public repository, but public repository means they can anyone can pull the code, pull the image, but they can't push the image. For that, authentication is required. For that, I have to run a command called as Docker login, and my Docker ID that is Sandesh 2026, and I have to give the password. So once I give the password Docker up password, then login is succeeded. Docker up password, you can create a token actually. You can go to your account and account settings, and here in security, you can create a new token, new access token, and you can create a token that you can use it as a password. So Docker login is done. Next, what next? I have to push this code, push this image for Docker push command. So it will push the image to Docker hub now. It is pushing now. So once that is done, now if I go here and if I go to repositories and Node.js app, so now the new tag version 1.0 is pushed a few seconds ago. So this is the image or image tag. Now anyone can pull this image to their VM or their local machine, and they can run the container. Then and that application will run. So now you can also pull this image. This is a public image. You can also pull this using Docker pull command. That I will show. For example, if I delete all the images that is there now, and I will pull the new image from the container or container registry, Docker images FNAQ. So it will delete all the images. It didn't delete it, and some config, I guess. Maybe I can use -f. Space is missing. Docker images. So all the images are deleted now. Then if I want to pull the images, I can use Docker pull. Pull this image. Version 1.0. And if I do Docker images, a new image is pulled from Docker app. And I can run this image now to create a container. Anyone can pull this image like this Docker using Docker pull. Then if I run Docker run, the application will be executed. So for that, I can run docker run. I want to run it in detached mode. And also, I want to remove this container -rm. And one more thing I want to add, for naming the image, I can use tag. For naming the container, I can use the flag -fn name or -n, so that it will name my container also. Uh, for now, for all the use cases, I just identify the container with the container ID. Now, if I want to give any name for this, like for example, node app, then I can give an app like this. Then I want to add the port, which is 3000, then 80. Then the image ID I have to give. I think image ID is Docker images. Okay. Or image ID, or I can give the name also, repository hyphen name. This also I can give instead of image ID. So Docker PS. See, now it has a name, that is node app, and it ran. And if I want to stop this, I can do Docker stop, and I can have no node app instead of container ID. I can give an container name also. So this is how I can identify images and tags. I can share the images using Docker Hub, and they can push, or any of my colleagues can pull the image from the directory. This is how it works. Okay, that's it. I covered most of the basic things in Docker. The advanced things are there, like creating the microservices using Docker, or next Kubernetes things, Docker Swarm. A lot of other things are there. But Docker Compose, those things are there. But that is not part of the. If advanced video is required, then please comment that. I can create one more video to cover these advanced topics. And also in comments, you can specify which DevOps tools you want to learn next. So I can explain those DevOps tools in DevOps tools. Then I can, if I know, I can directly create a video, or I can learn and I can create one more videos on that. So subscribe to this channel, so that you can learn any DevOps tools in like 1.5 or 2 hours. If you spend, then I can learn any new tools. So for that, you can just subscribe to this channel. Then one more thing I want to show you. I will just brush up all the things what we have learned today. So this is first we created an application using Node application. We created a Dockerfile image container. Then what we learned is, for building we run docker build command, and with the path name. Then for creating a container, docker run -p. Then the 3080, something like this. Then the image ID, and we learned several commands like -d for detached mode, -hyphen name for uh, identify the container, then -id for in interactive mode. If I want to learn, then you will learn docker start, docker stop. Then to list the container, we have docker ps, and to list the images, we have docker images, docker ps for container, docker ps -a for uh, listing the all containers. Then we learned a lot of things like docker pull, docker push, docker login for the sharing the images. Then docker exec for to go inside the container, and docker cp for copying the files. So these are some basic things we have learned. I think I covered most of this. And fn rm flag also I can use here for uh, removing the container when we stop the container. Lot of things. Any other things might I missed? but a lot of things I will covered in this course, this channel, this video for it. So next, so initially I told at the end of this video we should be able to teach Docker to others. That's the end goal of the video. So now you know the Docker, how Docker works. So I can explain some theories like difference between Docker and virtual machines now. So what Docker is process. This is virtual machines. We have the voice level, but the Docker is doesn't use voice. It share the voice from the host only. Then Docker is lightweight, but VM is dedicated resources required. So for stopping or starting the container, it will take couple of seconds only, but booting the VM, it will take minutes. Then performance, obviously Docker is faster than VM. All of these points are related only because Docker is lightweight, it is faster than container and it starts very fast deployment speed. And the portability, obviously Docker is portable and due to OS dependencies, our VM or uh, our Ubuntu VM, the what we created earlier, that is have the voice dependency. But containers, I don't have any voice dependency, and I can ins you can create a VM and I can host multiple containers on that. So it never like Docker versus VM. It's always like Docker and VM. We create a VM, and on top of that VM we can create multiple containers. That's how we have to use. Then the footprint and the scaling, obviously, horizontal scaling is very easy because we can create multiple containers inside a VM. And may requires in VM it requires more resources. So security might be one issues like if there are any kernel vulnerabilities, then if host kernel is have any vulnerabilities, then that might impact the container also. But if you use VMs, then obviously strong isolation will be there. Then easy management is obviously Docker is very easy compared to VM. So use cases, containers used in microservices, DevOps, CI/CD pipelines, but VM I can use any legacy application or OS need. If there are any OS needs, like one thing is these Linux containers can be hosted only on Linux VM. So any VM like Ubuntu, CentOS, any Linux variant, I can use Linux same image. This same image I can use it anywhere, but I can't host my doc Windows image on Linux because a container always uses host OS. So if the container is Windows type and the host is Linux, that won't work. That is, but in VM, I can in Windows Server I can create a Linux VM also because VM it has its own OS. But that is not the use case of Docker. Like we don't use Windows container on Linux. That is not the use case of Docker. Docker use case is lightweight dependency management, all of the portability. Those are use cases of Docker. Just for knowledge check, I will take a couple of seconds. Like first command, what is the command for creating the image? I have the Docker file. How can I create an image? Build the image. And yeah, just add the answer in the comments. And next command, next knowledge check is you have the multiple Docker containers. And if I want to stop all the running containers, what is the command? You can choose Docker stop, Docker kill, Docker pause, Docker rm. What is the command for that? Then the theory question, Docker containers provide which type of isolation, whether it's OS level isolation or process level, network level, or hypervisor level. Then if I have the image into my app and the tag is version 1.0 and that is the registry, then which commands I can execute to push the image. So this is the options. You can type the or comment the right answer in the comments. Then last question is like I have the Docker application, Node.js application. Then you want to stream the logs in real time. What is the command for stream the logs in real time? You can add those comments in the add the answers in the comments. So that's it. I don't take much of your time. Like if you want more videos on DevOps, any DevOps or cloud tools, please mention those in comments so that I can cover that topic or that tools. Thank you, and please practice this. Create a VM in GCP, then practice all these commands so that you will be well versed with this Docker, and you can teach others also how Docker works once you cover all these topics. Thanks. Share this video, subscribe to the channel. Bye bye.